So, welcome everybody. Thank you for attending this webinar about EcoTurbo, our solution for saving energy in dust collectors. My name is Corrado Maggi. I am head of business development in CleanAir Europe. CleanAir Europe is an Italian manufacturer of filter support cages for filter bags. This webinar will be recorded, and the movie of the webinar will be available through our channel some days later. Also, the catalog of the new product, which is called EcoTurbo, will be available as well in the next days. The webinar, we have not provided for direct questions, but at the end of the webinar, we will give you references of our email addresses in order to be contacted and eventually answer to your questions, specific questions. So we start now, and as I said, we called our product EcoTurbo Incremental Differential Flow Venturi Solutions. There are several ways to try to save energy, also in dust collectors. I mean, in a way that the decarbonization path is also something possible for the dust collectors. We will see how we can do this in our path. In order to legitimate the job that we did in CleanAir, we have asked the Politecnico of Milano, it's a engineering university of Milan, to follow us in a way that our tests will be performed correctly. And we cooperate with two different departments about this first study in computational fluid dynamics with the civil and environmental department of Politecnico of Milano, and later with the mechanics department to follow up with instrumental test on field of the findings of the computational fluid dynamics. So the domain of what we are speaking is in dust collector is jet pulse technology. In jet pulse technology, a pulse of compressed air is used periodically to clean the filter media. Filter media is a filter bag which is covered during the time by a dust cake. The dust cake increases differential pressure until a pressure for shooting and cleaning by provoking the dust release into the hopper. There has been several academic studies about the functioning of jet pulse, also in some experimental, some in computational fluid dynamics. That was the base of our research that we did. And particularly we focus on a document that was made by the Shanghai Engineering University by Liu and Chen in 2019. This test on field, on scale, highlights the fact that two parameters particularly, which were the peak pressure of the pulse and the arrival time of the pulse at the end of the filter, has an impact on the dust release of the filter bag. So by, let's say, releasing a more high quantity of dust. This study impacted on us in a way that we decided to investigate more the matter. And of course, we decided that the main first tool could be the computational fluid dynamics tool, which have a certain advantages, also some disadvantages. But among the advantages, the most important advantage was that it was easy for us to simulate different parameters, even if it was taking time, a considerable amount of time, and in a user-friendly way, and without spending a lot of money to set prior to instrumental test different scenarios of instrumental test to validate some assumptions. And so on the other side, the computational burden of the actual power of computers was limiting our actions. And so first we tried to understand how to solve this issue. And then also there is inside this kind of mathematical model a source of uncertainty because a lot of parameters have to be considered. As an example, with a lot of parameters, I can here speak about computational mesh should be decided like a time discretization, but also more typical mathematics equation of the Navier-Stokes equations must be chosen a post-processing with a sensitivity analysis, but this involves also fluid dynamic model like a gas equation, for example, so thermodynamic models, and the typical fabric filter models, like, for example, the Duffy laws. So all these parameters are impacting the results of the simulation that we, at the very beginning, we did. And we were aware. And so what we have thought is that we would have used computational fluid dynamic techniques by comparison from one preferred form, the EcoTurbo at the end, with on respect to what is already present on the market and in the range of the product that CleanAir is manufacturing. By comparing two different with the same model and same burdens, the two different devices, we can appreciate an eventual advantage in performance of one device against the other. So basically, this phase went from a physical consistencies analysis to numerical convergence impact of modeling, and so the standard deviations of what we have measured, observations, but also a defining of a potential more performant device with an experimental validation on field, so with some machinery, and then the final application of the device with design and manufacturing of the device. So basically, in computational fluid dynamics, we use first a two dimensions axisymmetric model in order to save computational cost for the computer. So we have modeled the tank, we've modeled the nozzle to inject, we've modeled the assembly of the filter bag with the cage and the collar and the venturi, because on top of the cage, we analyze also the area of the collar, which normally holds the venturi. In this situation, of course, a lot of parameters could be considered. As I said before, you can see on the right bottom graphs, we concentrate on the peak pressure, which is the black graph, and on arrival time of peak pressure. The probe was a 10 meters length filter bag, with an average diameter on the, let's say, typical of the market for filter bag cages. And we concentrate onto these two parameters, as the Liu Shen study, the Chinese study in 2019 highlights. The first problems we have was to consider the time discretization. At the end of our consideration, you can see that choosing seconds, 10 to -5 seconds, could be good enough in the sensitivity analysis for does not introduce significant change. If we make a longer time discretization, use a shorter pitch of the time. And so we choose to have 10⁻⁵, that is 3 days calculation for varying one of the parameters, for examples. And at the same time, we also have fragmented the meshes, into a 50K, so 50,000 small mesh to determine our model. Numerical convergence, so the fact that we can expect repeatability of the measurement and the sensitivity analysis has been performed by Politecnico as well. And Politecnico also introduced some consideration about the changing of the equation, mathematical equation, or let's say the background conditions that they use to completely simulate. So, for example, the compressibility effect or permeability efficient effect, and they make this study always with the aim not to determine an absolute value as a response of a model simulated, but a reliable model for comparison in between two different solutions. Of course, the first step we did was to consider the effect of a venturi towards a cage which has no venturi. And so that, of course, was the first step of the Politecnico to determine that the venturi could influence a jet pulse positively. Of course, at a certain bars, we made analysis with different tank pressures, of course, from 3 to 4 to 5 bars normally. And from this, we came to the conclusion that, as was anticipated in the Chinese study, some specific shape or, let's say, ratio and of the collar venturi could be helpful in determining an higher peak pressure and lower arrival time. So we analyzed with the computational fluid dynamic techniques different venturi and positions on respect to the collar. And we went to consider how sensible differences in between the behavior. And the behavior was not only relating as I said, the peak pressure and peak pressure arrival time, but at the same time was also impacting on the flow mass entrained into the bag. One of the defects of the venturi, especially in the working condition, is that sometimes venturi is closing the cell plate hole considerably, so forcing the fan of the dust collector to work more during the normal working phase, while it is, of course, facilitating the cleaning phase. So the second step that we made after this analysis, which took almost 1 year of analysis with PC computers, was that we have to define a dimensional quote for our systems. And because we wonder if there was any different quote that could help us in having a more potential peak pressure. And so the second phase, which lasted again 6-7 months, we vary each of these dimensions one by one and looking what was the figure out, what was the results. The results has been the EcoTurbo design of our device, a system collar and venturi, not only a venturi, but a system collar venturi. That is on the top of our cage proposal now. And it was tested against a well-known venturi available in the market, from which we have several installations over the years. What we discover, again, in computational fluid dynamics is, you can see in this graph, where on top you have both in the middle of the cage and in contact with the filter bag, the peak pressure confrontation from the traditional and the EcoTurbo, and the arrival time. Of course, this is inverted. That means that the more performant, the red one, which is EcoTurbo, has a low, more speed substantially in reaching out the end of the filter bag. These computational dynamic figures are very significant, and that was unexpected, frankly speaking, because Venturi tube is a whole invention of an Italian scientist, which belongs really to 400 years ago. But in computational fluid dynamics, we see doubling some of this value, like at 4 meters on respect to the traditional venturi, which is already considered a good performance in producing a wave of peak pressure. Of course, this introduced the need of further investigation. And also on the side of the quantity airflow or quantity of mass of air that is entrained in the bag, this increase was consistent, as you can see from the blue and the red one, which is EcoTurbo confrontation in this graph. We decided that we have to go on field, thanks to the help of the tank manufacturer. We went to use the facilities. We define some sensors with Politecnico of Milano that should be used to evaluate the pressure, peak pressure and times. Of course, some fittings need to be done, so we realize also the place where to place these sensors inside the cages and how to analyze the cage. And we choose, of course, a set of permeability and make some considerations also about the dust. And so the difference that impact the bag from new one, branded new one, to a used filter bag. What we discover first is that the curve of the pressure, of the peak pressure, increased dramatically, both on the positive side and on the negative, the pressure side, of course, on respect to the traditional. Again, was made by comparison. So, but with the aim also to see if the computational fluid dynamic results were confirmed by the test on field. Why I say saving energy in dust collectors? Because there are basically two ways. I mean, for me at least, but maybe others, of course, but which are evident. One way is that if we increase the filtering area, it will take more time to have a covering of a certain concentration of dust on the filtering media, and that will, of course, cause the cleaning, the delay of the cleaning frequency, a lower cleaning frequency to reach the same differential pressure. And this because you can increase the filter bag, like in pleated or in our product that we distribute for Italy, wave lines, where we have a bigger filter surface. Another way is the way of EcoTurbo is to insist on the mechanism of the dust release by trying to release a higher quantity of dust for each cleaning. The effect is on the graph on the right. That is decreasing the frequency of cleaning means lowering the average of delta pressure in the plant, and by lowering the differential pressure in the plant, we can save energy both for cleaning air compressed and also for the functionment, because it will require less power to push this air inside the system. Basically, and this is typical of the design of EcoTurbo, there are two aspects, because cleaning is impacting the Venturi color, or the shape eco design of the cage is impacting the energy consumptions in cleaning, and we have a solution to decrease the cleaning frequency, but also in working, because as I said before, sometimes Venturi cause some troubles to power increase due to the closing of the subplate hole for emission in the air. So it is important to find the best score in between these two curves, as it is highlighted on the graph on the left. And EcoTurbo has been designed also to solve this issue, basically without subtracting or subtracting a minimum section to the coming of in working conditions, to the emissions in air. On the other side, this is, of course, is introducing an economic advantage payback time, because when we have invented EcoTurbo, we have thought to have a device which is a sustainable device, reusable device, safer device, that is easy to install in old, just we need a flanged collar and new installations, and which is also economic in the sense that it's not costing differently from a normal traditional device. It comes in a design that allow to be used with other, let's say, accessories, like our EcoSmart. EcoSmart is a digital tag able to for making enterprise asset management, so carrying informations about the cage and the filter bag on board available for maintenance team, and we can mount our EcoTag on the top of these solutions. Of course, we have chosen to make it aluminum, which is a conductive material, which is the best solution also to work with our semiconductive cage in EcoAtex. And the space in between the collar and the cage and the Venturi is in the fitting system using a rivet is the best solution also to fix any anti-static copper strip in the case a protection against explosion and fire, like according ATEX directive is needed. It comes to the market in different sizes, able to cover 100% of the range of the cage actually on the market, used for different purposes and different sectors. In this moment, we have already available what we call the medium device. Medium device cover already maybe 65% of the market need in terms of sizes. So finally, which are the advantages? Advantages are up to 50%. The advantages that we found with the instrumental validation of the computational fluid dynamic model in a way that we can, let's say, declare these advantages to the market, is that we came up to 50% of peak pressure increase and 20% wave velocity increase, and a 50% more air intake on respect to the traditional solution. This is carrying, as I said before, to a lower delta P average in the plant and a lower energy consumption. There were, of course, people participating, attending to this study, which took us about 2 years, 3.5 to be completed at this stage. It's Corrado Maggi, of course, Mr. Montanelli is the CEO of CleanAir, was the first sponsor of this project, and we work in cooperation with Politecnico. We will present in a conference in Field Tech in November also this job, let's say the most academic part of this job done together. There's also a catalog which is available. I will just go very fast over the catalog, of course, domain and usage and advantages. And here you can see better pictures, for example, of the EcoTurbo in application with EcoSmart as well. And the patent, we have a European patent about EcoTurbo, because EcoTurbo is insisting on some specific section area in between the collar and the Venturi. So it's not that we invented Venturi, of course, but we invented a specific Venturi with certain advantages on respect to the traditional upper part of a cage, of a filterback cage. In the catalog is also explained the path that we developed towards the solutions, as I've explained, and some specific ratios about the collar, the validation made on field, and figures and numbers in order that people could rely on what we say. Of course, the energy savings is the aim of this system, which is a sustainable system, and towards the path that nowadays is the path of several industries towards net zero. We would like to carry our contribute for dust collectors in several industries. Just the last things, as you can see here, there is the waveline filter, so an increased surface filter that CleanAir is distributing in certain regions, certain area of the world. Of course, this is also possible to be equipped with Eco Venturi too. So I will switch to, let's say, our email. So if you have any information, need of information about CleanAir and about CleanAir, of course, and about EcoTurbo specifically, you can contact us at the 2 emails that are here, and I will leave this email on the screen for a time. I thank you for your attention. Of course, this video is recorded, so we will give back, we will contact the participating people back by giving on our website, also on our social media, the references to have access to this webinar, and to the information like a catalog that is just presented today. From today on, this product is available on the market, as I said, immediately already now in middle size, in size M. Thank you for your attention, and have a great rest of the day. We keep in touch. I hope that has been interesting for you.